Hello everyone. So we're going to continue our sessions on cache memory, and we're going to have this question here from the third exam. So consider a machine with main memory 128 bytes, right, and block size of 4 bytes. Data is addressed to a word, and words are 2 bytes there. Then what is the number and range of addressable memory locations? What are the block numbers for 12, 24, 43, and 54? Then assume a one-way set associative cache map. So 64 byte is used in this machine, etc., etc. Anyway, we'll encounter those questions as we go. But we're going to have the first part here, right? So first of all, I need to show you what do we mean by byte addressable memory, because that's what we're going to be using for this is addressed to a word and then word design. So for byte addressable memory, it means each memory location refers to a single byte, right? Each memory location refers to a single byte. So say we have our memory like this. This is not important. I'm trouble myself. Let's say we have 1, 2, 3, 4, 5, 6. So I have 6 memory locations. Okay, let me add 2 more to make it a power of 2. So if I have 8 memory locations, right? 8 memory locations. This is going to be 1, 2, 3, 4, 5, 6, 7, 8. Each of these are 1 byte. So I can say my memory is 8 bytes, right? Because each memory address here is referring to a single byte. Right? Each memory location here refers to a single byte, like that. Now, this is byte addressable. Now, what if we have something called word addressable? Now, what a word is multiple bytes, right? A word is multiple bytes. So if we say word addressable and here we're addressing 2 bytes, it means each memory location will have to refer to 2 bytes. So we're going to have this memory. So initially, let me put this in red ink. Initially, we have each of these being 1 byte each, right? But then, maintaining our memory here 8 bits, what if we say it's byte addressable and the byte and it's word addressable and each word is 2 bytes? Meaning we can say this memory location is 2, 2, 2, 2, 2, 2, 2, 2, like that. Ignore these ones here. Now, given this, right, we're going to have this one here, this one here, this one here, this one here. So 2, 4, 6, 8. Already we have 8 memory locations, right? We have 8 memory locations, meaning everything from this point onwards, everything starting here going down, we can ignore it, right? We can ignore this because we already have our 8 bits. We haven't changed the size of our memory, but we've changed the addressable space just by changing how we're addressing things. So initially here, for instance, if we needed let's say 3 bits, right? 3 bits to address this entire memory, because we have like 3 bits to address that one, because that's 2 to the power 3. In this other case where we only have like 4 accessible memory locations, we now have this divided by 2, which would be 2, 3 minus 1, which would give us 2 to the power 2, or 2 bits to access these memory locations, right? We just need 2 bits to access these memory locations. So we're not dealing with memory now, we deal with them now at a wider scale, at a bigger scale than just 8 by 8 bytes, as in 8 bytes is very small. Well, not very small, but I mean, it is small. At the time it was very big, but anyway. We're going to start now with 1 there, right? We're going to start with 1 there. So first of all, what's the number and range of addressable memory locations, right? What's the number and range of addressable memory locations? So first of all, we have to collect our data. I'm going to say data here, right? Our data. So we know at our main memory, right, this is equal to 128 bytes, which is 2 to the power 7. This is 2 to the power 7, right? Yeah, it's 2 to the power 7. Right? 2 to the power 7 gives us 128 bytes, right? But then we know that the word size is equal to 2 bytes, or just 2 to the power 1. So similar to what we did in that example, the physical address itself is going to be equal to 2 to the power 7 divided by the size of our words, which is 2, which is 2 to the power 7 minus 6, which is equal to or minus 1, sorry, which is 2 to the power 6. So this is a total number of addressable locations, meaning we need 6 bits for our entire physical address. So now, to go back to this question here, right? what is the number and range of addressable locations in main memory. So the number is equal to 2 to the power 6, right? The range is equal to, we start at memory address 0 all the way up to memory address 2 to the power 6 minus 1. We're subtracting the 1 from the entire thing, not from the 6, right? So it's just the possible range. So this is the range of values here. So just to step back, what did we do? We have our entire memory here in bytes, but we need to convert it to words because we're addressing words, not bytes. So what do? We divide our memory by the size of each word, which is, in this case, according to what we've been given here, 2, which gives us now 2 to the power 6, 2 to the power 6, 2 to the power 6 memory locations. Okay, now from this one now, what is first of all, we go back to our data here. I forgot something. So we have our block size, our block being equal to 2 bytes, which 4 bytes, which if we divide this by 2 gives us 2 words. When you have 2 words, because remember we're dealing with words here, not bytes. So what we're then going to have here is what are the block numbers addressed like that. Just a moment.